Meaning of stress, last time we have discussed. Okay. Meaning of stress, I have already told you. Stress means simple stress or engineering stress means load upon original area. And true stress means load upon instantaneous area. I have already discussed with you. Suppose here this is the diagram. So this is the diagram. Suppose this is the bar or member or bar or the solid rod. Suppose you cut parallel to base. Suppose this is the base. This is the base. Base means horizontal plane. Base, horizontal plane or ground. Okay. This is the ground. So with respect to ground, this is the basically ground. Okay. This is the ground. So parallel to this ground, suppose this line is this line and this line. This is the same distance. This is the same distance. Okay, means it's parallel. Okay, so this same distance and this same distance means here ground line and this plane are parallel to each other. So here we consider cutting plane or section plane. Cutting plane is section plane means cutting body. Used cut the body with the help of this plane. This is called section plane or cutting plane. So plane should be position of plane should be parallel to this ground. So if we cut parallel to this ground, so the remaining of first half here and second half removed from the systems. So this is the first half basically. This is the first half. In that first half, last time we have discussed some stresses are induced, means resisting forces normal to the plane and shearing forces parallel to the this plane. Two types of stresses are generated here. Now, like the normal stresses, like the sigma n and tangential stress or shear stress. Shear basically is the parallel to the parallel plane. This plane, so it means suppose you put your hand on the your hand, stretch your fingers, both fingers, hand and both hand rubbing. So both hand rubbing. So this rubbing action is called shear stress acting on your plane, your hand parallelly. So this is the hand, one hand and second hand. So if you have rubbing action, so you obtain the stresses, means shear stresses, means the friction forces are acting on that surfaces. So here the shear stresses occur on this plane parallel to this plane. Okay, and perpendicular to this plane that is called the normal stresses. So generally two stresses are occur in that cases normal stress and sigma. This is the P, not P. This is sigma and normal. This is the shear stress tau s, or simply you can say tau. Okay, so two stresses are occur, and here you see the normal stress, resultant stress. You can calculate resultant stress. So this is the formula we have derived the coming forthcoming lectures. So now we discuss here. So here we want to calculate the basically normal stress and the shearing stresses. So in that case, in practice, intensity of stress is called stress only. Mathematically, normal stress means sigma n. Sigma n, okay, is equal to limit delta area tends to zero. Means area tending to zero means minimize. Area should be minimized. Then delta R upon delta A is equal to dr upon dA. The R basically nothing but R is the force, means resisting force. No, here R is the normal resisting force. So here dr upon dA means dn upon dA means drn upon dA means dp upon dA. So here dp upon dA is the basically here the sigma n. So we consider here basically sigma n is equal to dp or df. Okay, df upon dA. Okay, area. So R is the normal resisting force. I mean F, R or F same things. So intensity of resisting force applied parallel to the stationary plane, I have already told you that is called shearing stress. So shearing stress basically delta A tending to zero means delta Q upon delta I, dq upon delta I. So here this is the shearing force. Suppose here dfs. Here dfn and consider dfn. dfs upon da. Okay. So this is the shearing stress and the shearing in that case shearing stress. Okay. Now here force means shearing force upon shearing area. That is called here Q is the shearing force. Means Fs is the shearing force or Qs or Fs same things here. So stress at any point may be defined as the resistance developed per unit area. Okay. So this is the basic concept regarding the stress strain. So simply differential form you consider only element taken. Suppose this is the body. Suppose this is the body here. So we have taken only one element strip. If you consider only one strip and integrate overall, we obtain the overall area. Okay. So here is basically consider strip means here d are equal to p means sigma and dA means PDA. Same things, PDA or sigma DA, same things. It is your choice. You can write and basically the it is notation. So no confusion in the notation. So integrate, we obtain the form in this form and apply the limit, obtain the formula for the resisting force and the shearing force. Now, suppose we apply the last time we discussed the what is tensile force, what is the compressive force. Suppose here applied last time we discussed. Suppose the body you have is stretching out. It is stretching out means this is the tensile force and P is the tensile force acting on the force tensile force. Then you see suppose after the tensile force some elongations are obtained and some contraction are also obtained. If you contracting the body, suppose if this is the body applying the compressive force. This is the compressive force. So here you obtain the some contraction. Okay. So but here we consider the simply the variation in the area. So length. Suppose this is the original length. Okay. And after the elongation, you have obtained the some extension in this bar. Okay. So some extension in this bar. So last time we have also I have discuss with you. Okay, now these are some elements you see like the this is the bar like the element specimen suppose uh, this is the specimen bar and this is the okay this is the gauge length okay so this bar apply means on the tensile test on a UTM machine ultimate tensile testing machine UTM machine. On a UT machine, you this component break in cup and cone shape, and after cup and cone shape, you see the patterns on obtained in the particular specimen. So here stresses are induced basically. Stresses are induced in that cases tensile stresses are induced. In that case, are this the tensile stresses are induced. So this is basically parabolic form here obtained. Okay.